Okay, so on notes 8.4, we're going to be looking at compound and continuous interest formulas. So on this compound interest formula, A is going to represent the balance after t years. Okay, so it's going to be your final amount. The P is going to be the original amount, so the amount that you're starting with. R is going to be your interest rate in decimal form. So when you have a percent, you'll change it to a decimal by moving the decimal 2 places to the left. So that's how you change a percent to a decimal, or just divide it by 100. N is going to represent the number of times per year the interest is compounded, and T is the number of years the interest is compounded. Okay? On the continuous compounding formula, you're still going to have A, which is the final amount, P, which is the original amount, R, which is the rate, and T, which is the time. So all of those are the same. The only thing different with the formula is there's an E here. E represents a number, just like pi represents a number. So there's an E button on your calculator that you can use. Okay? On number 1, the amount of $500 is deposited into an account that pays 9.5% compounded monthly. It wants us to find the balance in the account after 3 years. So let's start out with that first question. So we know that it's compounded monthly, which is not continuously, so we'll be using the first formula. And I'm going to write down my variables that are in my formula on the side. A is the final amount. So we're looking for the balance after 3 years, which is what we're trying to find. So we don't know A. P is the starting amount. The starting amount in the account is $500. The rate, it's paying, which means it's earning you money, 9.5%. So I'm going to change that to a decimal by either dividing by 100 or moving the decimal 2 places to the left. So it should be 0.095. N represents the number of times per year. It says compounded monthly, so that would be 12 times per year. And then T is your time, which is a 3-year period. So now let's plug into our formula. So we don't know A. P is 500. The rate is 0.095. Don't forget to change the percent to a decimal. And then that's over the number of times per year, which is 12. And we're doing 12 times 3 is your exponent. Okay, we can type all this in to the calculator to find our answer. So we have 500, open parentheses, 1 plus. I'm going to put my fraction in parentheses, so I'll write that on the notes here. So that would be 0.095 divided by 12. And then I need to close that set of parentheses, and then I'm going to raise that to the 12 times 3 power, so I'm just going to go ahead and put 36 there. And we're talking about the balance in the account, so we're talking about money, so make sure you round to the nearest cent. So $664, and that would be rounded to 14 cents. Okay, so once you're done with calculating it, make sure that it makes sense. So you're going from $500 to $664.14 in the account over a 3-year period. Alright, so the next question that it said was, what is the amount if it were continuously compounded after 3 years? So this time we're using the continuously compounded formula. We still have the same numbers, the same variables, so we're still plugging in. For P, we have 500. And then do not replace E with anything, because remember, that's like a pi, it represents a number. The R is 0.095 times 3. So there is an E button on your calculator. You can either do second divide and press enter. That shows you what E equals. There's also an E to power. So I'm going to type in 500, and then I'm going to use second and then the LN button, which is below log. is natural log, and so notice that it already puts that caret symbol there, so you could also use that one. I'm raising it to the 0.095 times 3 power. And so that would be $664.88. Okay, and then the last question, which would you rather invest your money? Notice that this is a little more, not very much, but a few cents. So of course you would want to do the one where you earn the most money. All right, number 2, your collection of baseball cards cost $150 in 1988. In 1994, the value of the collection had increased by 7.5%, continuously compounded. What is the value of the cards in 1994? So notice that it says continuously compounded, which means we would use that continuous formula. So A equals P times E to the RT power. So the variables that I need to write down are A, P, R, and T. So A is your value of the cards at the very end. We don't know that. P is your starting value, which we do know was $150 in 1988. The rate that it's increasing by is 7.5%. So changing that to a decimal would be 0.075. And then your time, we're not going to put 1994. We need to figure out how many years that would be. So subtract 1994 minus 1988. You should get 6 years. So I'm going to plug that in. And I'm going to type all of it into the calculator. So 150, I'm going to use the second ln, which is right below log. And then 0.075 times 6 would be your exponent. So we're talking about money, so that would be $35.25 would be the value of the cards in 94. So again, once you get your answer, make sure that it makes sense. It should be increasing because it said it increased, and you're increasing by 7.5% over that 6-year period. All right, 3, how much would you deposit into an account that pays 6.25% interest compounded semi-annually to have a balance of $5,000 in 15 years? So notice it said compounded semi-annually and not continuously, so I'm going to use the first formula. So I'm going to write those variables down. Okay, so A is your final amount. We know that this time. It's $5,000. That's how much they want in the account after 15 years. P is your starting. We don't know that. That says how much would you deposit at the very beginning. We don't know that amount. Rate, it's paying, which means it's increasing by 6.25%. So 0.0625 would be your decimal. Number of times per year. It's compounded semi-annually. That means twice a year. And then your time would be 15 years. So I'm going to plug in the formula. This time we don't know P. Oops, that should be 2. Alright, so this time, since we're having to find P, we need to get P by itself. So what we would need to do is divide by that number on both sides. Okay, let me show you how you can do that in the calculator, because you don't want to find that number by P and then round that and then round again at the end, because that won't be the most accurate answer. So what you can do is 5,000, or actually, let's find the number next to P first. So 1 plus 0.0625 divided by 2, and then raise that to the 30th power. Get that answer. So like what I was saying, you can't round that and then divide it by 5,000 and then round that answer. So what I can do is 5,000. I can divide it by that answer that I just got in my calculator. So you can recall an answer, so second, and then the negative key, and then that would give you your answer there. So P equals $1,986.33. Okay, so this time it went down because we're looking at the starting amount. The starting amount should be smaller than that ending balance if it's increasing. So again, just make sure that it makes sense at the end. All right, so all those problems were increasing. There are sometimes when it decreases. Okay, so what you will do is you'll just subtract on your compound interest instead of adding. So let's look at 4. The value of a new $12,500 car decreases, so we'll be subtracting, by 20% per year. You're finding the value after 3 years. So we'll be using the formula, but we'll be subtracting this time because it says decreases. If it says depreciate, decreases, it's going down. Okay? So I'm going to write my variables. A is your final amount. We don't know that. We know the starting price of the car was $12,500. The rate that it's decreasing by is 20%, so that would be 0.2 in decimal. And it says N, which is the number of times per year. Notice it says 20% per year, so that N would just be 1, and then your time is over a 3-year period. So plugging in. So when you're plugging in, you should get something less than, because you're subtracting. Notice this time, since we're dividing by 1, all I would have to put there is 0.2. We're raising that to the 3rd power. So you should end up getting $6,400 would be the value of the car after 3 years. So it's depreciating, it's going down.